All right, on to the next part. All right, let me clear this first. All right, on to the next part about simplifying radicals. Okay, they are very easy ones. Not only we have radicals, we also have something with complex numbers. Now, I'm not too worried, except for questions like 7, 8, and 9. That will be my top concern, because I hope everybody knows how to simplify. Now, my top concern is some people would just do simplification like this and write down this as the incorrect answer. This is wrong, by the way, okay? Now, the proper way to see it, okay, the proper way to see it is that this is a single denominator, as I explained before, and this is how you can look at it, and that explains why this particular 2 would simplify with these two numbers simultaneously, because I mean you have a single denominator, that's a common denominator, so you gotta, you've got to simplify both terms. So it takes a little while to get used to if you are not if you were not comfortable before, but you just have to see the reasoning. You've just got to ask the why. All right, why are we simplifying both numbers? Why is this 2 simplifying with the 10 and the 4? Well, that's the why. Common denominator. For number 9, so what you got to do is to make sure that you simplify this square root of 20. 20 is 5 times 4, right? So 2 root 5. Okay, so again, you would simplify all these numbers. So you've got 1 minus root 5 as your final simplified form. Okay, now sometimes it may not be completely canceled, some completely reduced. So you just find the best number to reduce. Okay, so in this case, it's going to be 2. So minus 3 plus root 3. Okay, and that would be it. That would be it. Okay, that would be it. Cool. Okay, that's my top concern about simplifying radicals, and then as for complex numbers, you know, so gonna expect to see something like this. Okay, it won't be disappeared. It will be there on the test. So we just hope that at this moment you can really factor these numbers very quickly. Like 8 is square root of 8 is 2 root 2, and you know why it's 2 root 2. Square root of negative 18, or 18 would be 3 root 2, or in this case 3i root 2, because 18 is 9 times 2. And this one is just simply 3i, right? And these two are like terms. 3i is kind of weird, not really the same kind. So you have 5i root 2 as your 5i root 2 plus 3i as your final answer. Okay, so just make sure that you are taking the like terms into consideration. All right, now, other things about complex numbers, or these I thing. Just make sure that you know, okay, like for number 10, you are only multiplying I over I. Okay, 4, it's not necessary because 4 is not the problem. The problem is the I. We want to get the I away, all right? And when you have things like this, okay, please don't do I over I, because you have a minus right here. You've got to make use of conjugate, okay, multiplying by the conjugate, 2 plus I over 2 plus I. And why on earth are we doing this? Because 2 minus I and 2 plus I gives you 2 squared minus I square. Okay, so and the top will be just a little bit of a mess, okay, but it's okay. And then the denominator is going to be 4 minus I square. And do you know what I square is? I square is negative 1. So therefore, it's 4 plus 1 in the denominator, 6 plus 3i in the numerator. So that just becomes 5. So 6 plus 3i over 5 is your final answer. All right, so yeah, so it's just things like this that would keep me awake, making sure that I will be a little bit worried about, do you know when to do I over I, when to do the conjugate, so like how good your eyes are. Okay, and like what I said earlier with the previous page on simplifying radicals, like can you simplify this? Can you simplify these? Okay, same deal. You take care of the square, you take care of the square root first, and then you simplify it accordingly. So I'm gonna do number 14, okay, just to show. So you have 72, that is 36 times 2, right? So that means 6i root 2 over 6. Now you can do it a couple of ways. You can say, well, I'm just going to go ahead, divide it by, I mean, not divide, I mean, yeah, reduce it by 2. So you have 5 plus or minus 3i root 2 over 3. That works. Alternatively, you may also do 10 over 6 plus or minus 6i root 2 over 6. And the benefit is that you have one less fraction to deal with, because 6 over 6 is 1. So here, it's just 5/3 plus I root 2. I would take either one. That's fine. Okay, they are the same thing. They're equivalent. So, so yeah, so that's how we will take care of these simple simplifying radicals, and well, radicals with a negative number, which gives us the the imaginary, the I thing. Oh, by the way, yeah, so these like 1i to the gigantic power, again, you want to make sure that you have a what is it called? A multiple of 4. Okay, you break it down and you want to make sure that this is a multiple of 4. And why? Why? Because I to the multiple of 4, it's always equal to simple number 1. So you just have to take care of I cubed, which is negative I. Okay. So if you missed that part, make sure you rewatch or review the topic, the notes, or the video. Okay, so that's really what I want to talk about with the radicals and complex numbers. Next, it's about discriminant, standard form. Okay, all kinds of stuff there. All right, so stick around.